Hello, pre-calculus student. This video is for chapter 5.2. We're still in the process of defining sine and cosine function. Last time we say, okay, x is cosine t, y is sine t. T is the input. Where's t? Where's my input? My input is an angle that go from the x-axis clockwise or counterclockwise for positive, clockwise for negative, until you hit a terminal side of your angle. And then this intersection to the unit circle would have a point of xy. X would be cosine t, y would be sine t. So you don't need to calculate anything. You just need to look up what that x and y would be after you put in your angle. Now, all the other angle, I really don't know what point it cut, right? So you can like, for example, like what we have done last time, when we look at the unit circle, if I draw a x, y here, so last time I try to do this one and make this, yeah. Maybe I'll do black this time. And I'm going to try to draw this. So for example, I want to do sine 10 degree. So I'll draw 10 degree. I don't know if it's really 10 degree, right? I'll cut this point. How do I read it off accurately? That is like round to 4 decimal place is not possible. So in general, you would require to table lookup or graphing calculator or calculator to read off the x and y. But the way the definition is, this is the number x would be cosine of 10 degree, and then sine of 10 degree will show up that cut the unit circle. But there are several angles that I can actually accurately tell the x and y. What value are they? They are called coronal angles. So let us go back to the notes. Exit drawing. Otherwise, cannot go back. So, what are those angles? Coronal angles are the angles that falls into the x-axis and y-axis. So, see how this is. I want to find cosine 90 degrees. So, remember, we can do this with the right triangle. We have to use our definition. So, I'll draw the picture of the unit circle, and then I'll draw my degree of 90 degrees. So, it would be starting from here. And then this is 90 degrees. This is the terminal side. It cut the x-axis, like cut the unit circle at what? 0, 1. And what happened is the cosine 90 degree would be the x-coordinate, right? My x-coordinate is equal to 0. And the y-coordinate, cosine 90, will equal to x is equal to 0 because this is the angle 90 degree. Then sine 90 would be the y-coordinate. And in our case, it is equal to 1. That is exact. But I don't have to guess it is 0.8 or 0.81 or something. So 0 sine 90 is 1. That's how you produce those. What about cosine pi and sine pi? So if I don't see a degree, pi is a radian. So how do I draw pi? Pi is here. Pi is just 180 degree, right? 180 degree in pi is the same thing. So this is pi, and it would cut the unit circle at what? If you imagine this is the unit circle, this is -1, 0. Cosine is equal to -1. Sine is the y value equal to 0. So we would just, so for this 4 point, I would be able to find sine and cosine of 90, sine and cosine of 180, 270, 0 degree, and 360 degree, or any coterminal to those 4 because I can read off the x and y. So basically, that's what we do for those coronal angle. What about if it is other things, other angles? So let's look at, before we do the other one, let's look at some interesting things between the sine t and cosine t. So there is a identity called the Pythagorean identity, where sine t squared plus cosine t squared is equal to 1. Why? Because this is actually the unit circle's equation. The unit circle equation is, I think I want this darker too. Yeah. Right. So the unit circle equation is x squared plus y squared equal to 1, right? But x is cosine t. And if I square it and sine t, if I square it, of course it's equal to 1 because that's what happened in the unit circle. And we also I want to also mention the notation of sine t and cosine t. Usually when we do function, our input is with the parenthesis t or input, but we can write it without the parenthesis. And if we want to do cosine t or sine t squared, sometimes we write it as the square next to the cosine. So this just means that these two are equivalent notation. Okay, so if I want to say cosine t squared, I would wanted to write it as cosine squared t plus sine squared t equal to 1. So this is called an identity, and its t is any angle. It could be the coronal angle, it could be any 30 degree, 40 degree, 10 degree. So if somehow I have a angle t, I don't know what it is, but when I turn my terminal side, it cut the x-axis, cut the unit circle with a y equal to 3 over 7. So sine is y, right? So it means y equal to 3 over 7. And t is in the second quadrant. So imagine this is, say, t in the second quadrant. That means I have a unit circle. I draw this. My y coordinate is 3 over 7. So I have an x comma 3 over 7 that cut this. What is cosine t? Cosine t is x, right? So I would use this Pythagorean identity that say 3 over 7 square. This is the identity. Plus cosine t square, or cosine square t, is equal to 1. And I actually square it, 9 over 49 plus cosine square t is equal to 1. Subtract over. Continue here. I would have cosine square t is equal to 49 over 49 minus 9 over 49. 1 is 49 over 49, right? It would be 40 over 49. This is cosine square t. I want cosine t, I have to take the root. Should I do plus or minus? For cosine in the second quadrant, cosine is positive. So we would just do 40 over 49. So 40 is square root 40. 49 is 7. It's positive, right? We do not need negative because it's in the second quadrant. So this would be 2 root 10 over 7. And that is my cosine t. So you can use this. If you know one of the x and y value, you can use the fact that it is on a unit circle, x squared plus y squared equal to 1 to solve it. So let's do some calculation. What is the sine of sine t and cosine t if the angle is in quadrant 3? Quadrant 3 is here, right? This is quadrant 3. What are x and y? X and y are this point. This point is both negative, right? If you draw it, you know, oh, I have a point in here. If cosine t is positive, where can the angle be? Cosine t is x value, right? Where is x positive? It's here, so I could have my angle either here or here. So the angle could be in quadrant 1 or quadrant 4, right? Cosine is x is positive, x is positive is x value. Y can be in quadrant 1 if sine is positive. Y is quadrant, the angle is in quadrant 4 if y is negative. 4. If cosine t is 24 over 25 and the angle is in quadrant 4, well, in quadrant 4, sine t is negative, right? So find sine t. So I'm going to use the Pythagorean identities. Cosine squared t plus sine squared t is equal to 1. Cosine squared t plus sine squared t is equal to 1. So cosine t is 24 over 25. I square it plus sine squared t is equal to 1. Just like before, we subtract over. So sine squared t would equal to 1 minus 24 squared is 2. What is 24 squared? I don't know. Oh, how come this one is still here? Oh, yeah. Okay, so let's do the 24 square, 576, 25 square, 625. 625 over 625 minus 576 over 625. 576. 625 minus 576. 49. You go to 49 over 625. That's sine squared t. So sine t would be square root, but negative. Why? Because I noticed that it is in quadrant 4, has to be 49 over 625. Square root top and bottom, negative 7 over 25. So this is equal to sine t. So I can find sine t if you know cosine t. So that's the relationship between sine t and cosine t. You put in the cosine square plus sine square t, you can find each other. So I'm going to stop here, and then the next video we'll talk about special angles where I can actually read off the x and y value when I have special angle. What are special? 45, 30 degree, and 60 degree.